How you doing, everybody?
What up, Joe?
So the first thing I want to do is make sure all your phones are off.
Oh, I got you.
So let's just see who still has a phone on. Might take a second.
Yo, if my number pops up there, I'll bug out.
Better not be getting my number. Oh my god, this is hell cool.
Oh my god, they've got swag everywhere. Everything. Eater.
So is he gonna know if I don't?
Alright, so it looks like there were a bunch of ones that were earlier. There were a bunch on earlier, but it seems like that people did shut them off. So thank you. Alright, so we're here today to talk about innovation hacking and free and open source software, right? So I want to explain each one of these terms in a little section of the talk. The first two are kind of easy, and then Foss is like a big thing to explain. All right, so the guiding part of this talk is going to be that Foss is a philosophy and a suite of technologies to make innovation and liberty possible, right? So those things are important to me. I hope they're also important to you. But first, you know, what do all those words mean in there, right? What is Foss, right? And then why should you care about it, right? So that's what I want to portray to you today. So in the blue wing downstairs, you probably already saw it. Go down after the talk if you didn't. There are all these people presenting different projects. So how many people talked to somebody at the table already? Just raise your hand. All right. What were your favorite table presentations so far? Shout it out.
Build your own PC.
Build your own PC? Okay, did you go and build your own PC?
Yeah.
All right, awesome. Who else was at the build your own PC thing? Okay, so you got to check it out after that. Cool. So the first term, very, very easy to explain, innovation, right? Innovation. The development of new solutions. So solving some problem, right? It's pretty straightforward. There's no controversy with that term, right? Hacking, on the other hand, is a bigger problem to explain. So for today's purposes, the word hacking does not mean breaking into stuff and stealing tons of information and posting stuff, whatever, on other sites on the internet, right? It's going to be creating something new from basic parts, right? So if a set of core components, using that, recreating them in some way, melding technology to, at your will, to do something that you wanted to do. Another component of that is deeply understanding details of technology. Right? So you have to understand deeply how everything works to recombine it. And then using that knowledge to regain liberty on devices you own, right, or things in your life. So these terms aren't really align with the word hacking that you guys probably have heard, right? I think of like hackers as bad guys. So that term has kind of been hijacked. So it really needs a whole nother word to describe what this part of hacking means, which is the root, the old definition, right? Which is a philosoph, right? So this is a Enlightenment era person who believed that all things are not black boxes and magic, right? They can be broken down into core principles, right? So in that time, they were talking about that in terms with religion, right? To say that, you know, it's not magic how everything works. Everything's basic fundamentals. They're atoms. I don't think they knew about atoms back then. Now it's even deeper than atoms, right? So we have Higgs bosons and stuff to worry about, and then we'll probably go smaller than that. So that same terminology scales to today with devices, right? So you have a phone. How does it work, right? It's not just some black box. Like a person made all these things, or a group of people made each one of these components. So they're all understandable by people, and we can all know how all that stuff works. All right, so what is Foss? Free and open source software. Right, so how many people have heard of free and open source software before? Besides, like, since you started scheduling for this event? Okay, good, okay. So primarily it's directed by the Free Software Foundation. They do a lot of work in here, but you know, it's free software, so they don't really control anything, right? They just help out. So if there's a niche that needs something to be fixed, they usually do it. People donate money there. So the biggest controversy, or the biggest thing that people don't get is free is in freedom, right? So it's not free is in zero cost, right? So this is freedom is in liberty, right? To do things with your devices. And this can be broken down into three more subsections, right? So we have Foss is a philosophy, Foss is practical, and Foss is industrial. The philosophy of Foss might be a little boring, right? But these fundamental things that make up free and open source software enable this larger amount of things to actually happen, right? All right, so first, let's go over the philosophy. All right, so the freedom to run a program for any purpose, right? So if you get some free and open source software, you can do anything you want with it. There's no bar, right? So sometimes there'll be a license that says you can't do something, right? That is not free and open source software. All right, the freedom to study how the program works and change it, right? This is what open source usually means. If the source is available to you to inspect, right, and recompile and modify, right? So this is just by itself, you can look at the source code. But this doesn't say you can redistribute it to other people. Like if you just said something's open source, right? So if it's free and open source, you can look at the source, modify it, and compile it to do something different. So if you have a PlayStation and you have a loading screen, you can replace the loading screen with kittens playing, right? So instead of watching a spinning disc, you watch some kittens doing, I don't know, playing where they play, right? Which someone should do that because I'd like to see that instead. So if you get some ideas from this event, go and do that, and then send me an email so I can install that. So the other thing is you have the freedom to redistribute those copies. So if you modify the source code, you can give it to somebody else. Like you can give me a copy of the source code that you have access to. And then you can also distribute copies of the modified version that you made. So you can not only give you the source code for PlayStation, you can give you the source code for your version of PlayStation, right? PlayStation's not free and open source software, so that gets really hard, right? People might act and try to pretend that it's free and open source software when they break into it and look at how make stuff that works on it, but they're going the hard road because free and open source software is really easy to modify stuff, right? Like you'll see with Raspberry Pi and Arduino, all the crazy stuff you can do with it. The base of that is all free and open source software, so you know how everything works on top of it, right? So if you don't understand how something's working, you can actually look at it, and then once you have the deeper understanding, you can do something more interesting with it. All right, so that's a philosophy. It's boring. I don't know how many of you want to be philosophy majors, but why should you care? So a lot of this talk, I just want to convince you why you should care about these things. Right? So I'm going to have 4 examples. Medical, really cool stuff, and then liberty, right? So the first thing is Ensalada. Right? This is a project that this guy's working on. So he has diabetes, right? He has to wear this glucometer all the time that administers insulin to him, right? And it turns out that it's closed, right? So he gets this device and he wears it all day and he has no idea what it's doing. He can only assume and hope that the device manufacturer did the correct thing so he's not getting tons of insulin at some amount of time, right? So this device actually collects information all day about him, and he doesn't get to see it, right? So it turns out that with the current laws, and there are laws to protect people who have this, who are giving information to like a doctor or something, right? So they can access all that information. But in this case, there's a loophole where they send information to the manufacturer instead of the doctor, and then the doctor doesn't have access to it, and the laws don't apply. So really, he doesn't have any access to this information. So what would an engineer do, right? So this guy reverse engineered this glucometer, and this is a really like a high-level algorithm, a high-level, how it interfaces with the device. Much more details of how this whole thing works. And then he wrote a script to actually read the data off this glucometer to look at his therapy and actually audit that he was being administered the correct doses at the correct time, right? And he did it in Python. If you haven't, you probably saw it. There's an exhibit down there talking about Python today. It's a very versatile language. So here's his prototype. So this is the glucometer on the left, and then he carries around this thing or has it in his house, and it reads the information off the glucometer and then sends it to somewhere he can read. So he can get an email report every day that says, this is what your therapy looks like, right? And he has full access to all that information. So that's one way of using his in-depth knowledge of technology to enable himself to regain liberty on something that he owns, right? So he's now in control of his therapy. And then these are all, it's an open source board. I don't know the name. It's not a Raspberry Pi or anything. It's something else, but it's all on the same lines. And then he's got some USB dongles, and there's a Wi-Fi thing there, and I think one of them is Bluetooth. Okay, so another cool thing, and an area that I really like is phones, right? So everyone has phones. They're really interesting. There's a group of guys. They call themselves Ninjatel. It's like they make their own cell phone company. So they demoed this at DEF CON last year. How many of you guys have heard of DEF CON? Okay, so you should go. It's very educational. So there's this group, Ninjatel. This van you see in the back, that's actually a cell phone base station. So it's something that like AT&T would run, right? But currently AT&T like stops other people from running it by having nice closed source technology. So this antenna is huge in the back, and that's actually that's broadcasting all throughout this casino that they're in. So these phones that were given out during the event all connect to this cell phone tower, and then you could put your own phone there. But it's a fully free and open source software cell phone network, right? So you can do that around here. You could put one in Boston Common, and you have like most of Boston hooked up there, on the top of the credential, right? It's really easy to make these, well, it's not really easy, but it's really cheap to get this stuff together. And if you have the knowledge, I guess it gets pretty easy. And it's about like $1,400, and you have your own cell tower, right? All right, so how would someone do this? So I talked briefly with them on how they'd actually make this thing. But the guys who were, it's a pretty dispersed group, right? So I didn't talk to all the guys to get the whole thing to work. And there were no chalkboards, so no one could explain to me like really the details of this thing. So if I was to set this up, how would I do it? Right? So you have these cell phones at the end, right? They connect over some SIM card that you have to buy, so you understand the second half of the encryption on the SIM card. And then you hook that up to some antenna, which you saw on the thing. That's going to hook up into a USRP, which is like a Universal Software Radio Peripheral. And it's sold by a company. It gets around FCC regulations, so you can do whatever you want with radio spectrum. So you can just say, I'm going to be a cell tower on this frequency. All right, then to run that USRP, we're going to use New Radio, right? Which is a free and open source software platform. I'll go into more detail on this in a second. That's configured using OpenBSD, which is a free and open source software package. And then you actually hook that up to route all the calls using Asterisk, which is a VoIP server, a SIP VoIP server. And that's going to connect to the internet to attach to other, or to trunk to other phone networks. It's also connect to plain old telephone systems, and also VoIP clients, right? And other phones are going to be routed, in the reverse direction, right? So you can connect these together, and you can have huge networks and run a nationwide cell phone network, right? All right, so USRP, what does it look like? It's this box with tons of hardware, and then you have these connectors to run antennas, and sometimes you have to put these into amplifiers to get the right power coming off of these things. But you have this piece of hardware, that's the most expensive piece in this whole thing. And then that's actually, I think, the only thing that costs money. And then you have New Radio, it's just going to process the frequencies for you, right? And then Asterisk is going to actually connect these calls, right? So when you make a call to somebody, you're actually calling an Asterisk server and saying, hey, is Joe connected to the server? Can I make a call to him? And then it'll say, oh yeah, he's here, go talk to him. And it'll just connect the call, all right? And then you get some really crazy stuff. So if you use this client, and it's all open, right? So anyone can make a client that works on this system. So SipDroid VoIP client, right? You can make your own cell phone network, right? So if you don't like how numbers work now, someone just made those up years ago. You can just make them up again, right? So you can call like 102, or like, you can actually call things with names. You can say, I want to call Joe, and my number is JOE, right? And it doesn't map to some keypads. It's actually the string JOE is gonna be my address, right? Most people turn this into emails, and then you can call an email, and you don't have to use a cell phone system, or you use the Wi-Fi or any IP stack that's around you. So if you happen to be in the middle of nowhere, you can put a telephone system there. So people do this. There are parties in the middle of nowhere, and they have cell phone systems, so they can all just talk to each other, right? People just like grab a bag of all this equipment, just plop it down and plug it into a generator, right? And boom, they have all this whole infrastructure, and it's like miles. Cell phone. The reason people use cell phone systems instead of Wi-Fi is the range is so much bigger. So this group, the Ninjatel people, can't afford federal permits because they're like millions of dollars. So they can't release this to you and me. They have to hide it, I guess. So, all right. So that's interesting. Who thinks that's a cool thing? Who wants to make their own cell phone network? Okay. One other question I want to ask is how many people have like taken apart stuff in their house? Like, so you get like a phone and it doesn't work, or a CD player and you just rip it apart. or something else. Yeah, so I used to do the same thing when I was a kid. I took everything apart. The hard part's putting it back together. So who's taking something apart and then they can't put it back together? Okay, did you get in trouble for that? Okay, yeah, that's okay. You know, at some you gotta break a few, you know, CD players before you can do it, right? Okay, so how many people have jailbroken or unlocked a phone or device, right? So, or a PlayStation, like you've put your own operating system on it, or you've taken, like, you bought some piece of proprietary software and then you've imposed your own software on it to make it do something that the manufacturer didn't want it to do. All right, that's it? Okay, so a lot of people. I think everyone's scared to put that up already. It's okay, it's okay. You're among friends here in this thing. So now I'm going to talk about unlocking your own hardware. So one of the tenets of free and open source software is the liberty to do anything you want with what you own. Right? If you get some piece of hardware and the person said this is Foss, that you can do whatever you want with it. Right? So they can't say you can't do this. Right? Which some companies are able to say that you can't do this. Right? So Sony says you can't show people these keys. You can't see that, right? Like, so there's some guy, this guy GeoHot. I don't know if you've heard. Who's heard of GeoHot? So you guys all know PlayStations or something. So you publish these keys, and they allow you to make your own operating system for the PlayStation. And then Sony actually sued him, and then one of the things that he had to do for the suit was work for them for a year, right? So like they sued him into that's their hiring strategy, right? But it worked. So he can't find these keys anymore, or they're really hard to find, right? So people get like they'll try to tell people, like, don't show people these keys because it's breaking our future use of the Sony PlayStation console, right? Same thing with iPhones, right? So you probably jailbreaking iPhones, right? So so I guess one thing on iPhones you can do is when you jailbreak it, you can download all these apps. That's one thing. But so if you jailbreak like an Android phone, right, you don't get free apps, right? So that's not the point of this. It's more about doing what you want. So if you want to run your own, if you want to tether, right, and AT&T said no, right, the device can do it, right? All these devices can tether, but the software is actually written to stop you from doing that, right? So when people jailbreak phones, it's to do the stuff that you can't do with that hardware platform because it's more restricted, right? And then also to talk on any cell phone network, right? So you guys don't remember this, but you used to be able to roam on other cell phone networks. You can't now. So the only way to talk on like a T-Mobile network is to actually get a contract with T-Mobile. Or you can go with a company from outside the United States because they still have roaming. But most of the stuff is restricted. So if you want to do stuff like that, you actually have to unlock your phone. So people do that for iPhones, and then they put a different SIM card in and do stuff like that, right? So those are the strategies people have used to deal with these closed devices. So I want to ask you guys a question. So these are the two options that I think, I'm kind of presenting them, right? So we talked before about, like, you get this free and open source software, this free and open source hardware that follows the same principles as the software, and you can do whatever you want with it, right? But then if you have a device that doesn't adhere to this, you might have to break into it to regain these essential liberties, right? So what side do you guys stand on this issue, right? So let's go into break-in devices. Or how about this? Each person turn to their neighbor for a second and talk about which one you would pick.
Yeah. Sometimes talk, guys.
That's right, I'll pick you up. I eat in this hole.
Gingerbread, yes.
Joe,
Frosted.
you're gonna tell me to walk around more.
All right, so that you guys should have been able to do that now. No, someone has a Galaxy tablet somewhere on. So I guess it's not a phone, so you weren't asked to shut that off. But you might be Professor Miller or something. So let's see a show of hands. So who thinks we should break into devices? Oh, I didn't raise my hand. Well, I guess I'll do it. But who thinks we should buy hardware that respects them?
Never.
I didn't see if that overlapped. Was there any intersection there? I kind of believe in both, right? But sometimes it's necessary, right? But I'd much rather buy the hardware so I don't have to do this stuff because it exists. It's just a little bit harder to get to, right?
Yeah, a little more money.
So maybe let's get some input from some people, right? So if you raise your hand, Emily will come to you with a mic, and you can say like what side you're on and why, right? So no hands.
Now, personally, I can't really pick like which one I'd be on.
Yeah.
Like, I'm pretty much 50-50 on both choices, but like it's tough to answer. But sometimes I like to break into devices. Well, I don't do it, but I prefer to break into devices. But I would also like to buy hardware that respects me from the get-go, instead of getting my liberties taken away later on, and then have to like reclaim them through breaking them in.
Yeah. It is a hard choice, right? So
No reason for that.
So sometimes it's a hard choice. If you buy something that's like a fraction of the cost and then break into it, you might seem like that's another valid option, right? But in the future, you're also saying I like that model, right? So if you continue to buy devices that are closed, right, you then will never have the option to buy these ones that are free and respect you. Do you have another question?
I believe you should be able to break into your device because people pay really good money for phones and tablets and computers.
Yeah.
What is it if you can't customize it and really make it yours?
Yeah.
So, obviously my side is with breaking into devices. You should be able to do with what you want with your technology.
Yeah. Okay, so yeah, it seems like a lot of people are on both sides, and it's a hard choice. We have another hand.
What are you trying to say?
So let's be respectful and listen to what everybody has to say, okay?
Yeah, we are.
I actually have been I've actually taken this into consideration every time I buy something, and I actually refuse to buy something that doesn't do both. Like, I will not buy something if I can't open it up and change the software at the same time. I simply will not support it.
Yeah. So that's pretty much, if I'm going to buy something and have to break into it, I would opt to not buy it. Good. No round of applause for that guy. That was. We have another one here.
I choose to break into devices because I think I want to have a challenge. So that's what I think.
So that's a good point of view. You can also build something awesome with hardware that you can do, like a gigantic cell phone network that runs in your whole house. But yeah, so this is an interesting point of discussion. So it's good to keep in mind when you're buying stuff, right? That there is a choice, right? Some people want what's on the right, but they've never known that it was called free and open source software. They never knew what principles they should have for buying this type of software, what to look at, right? So if the free software philosophy, right, allows that you're not going to get burnt in the end, right? You're not going to buy some phone, and if you're denied one of these rights, or if you have all these rights that free and open source software has, you're not going to, down the road, you're not going to be in trouble and not be able to do something with your phone that you want to, right? So it's a good guiding principle when you want to actually make a purchase. Okay, so for the people who are jailbreaking their phones, do you know what you did? Okay, so I'm gonna go over how jailbreaking works. So the anatomy of most devices is laid out like this. So this is like for Linux. This is the Linux kernel. We have this dividing line, this dashed line right in the middle. Below that line is everything that runs privileged, right? It's called the kernel space. You guys have heard of the kernel at some point, maybe, or you hear it when you talk to those people down there. So this stuff runs with full access to do everything on the device. This code that runs in this bottom space has access to your personal information, your contacts. It can make calls on your behalf, do all this stuff, right? So the target is usually to break through this wall and get to the kernel space, right, from user space. So normally, like your applications that you run, they run in user space, right, at the top. So they run on top of this line. And the only way they're allowed to cross this line is doing approved, sanctioned calls into the kernel, right? So you can compile your own kernel, right, and it has extra calls. But for security, we want to have any program run, and it can't do whatever it wants with your computer, right? There are certain limits, right? So when you have something that's not an administrator or root on a machine, they can't run anything they want in the kernel space. So how do you get into this kernel space? So when you run these jailbreaks, right? What they're actually doing is exploiting your phone to get some code in that kernel space, and then they can go around and do whatever they want. If you pay for it, they're definitely going to jailbreak your phone or something, right? They're definitely going to open it up for you. But what else are they doing? They have full access to do whatever they want, right? So usually viruses come from these realms. So if you get some free software from the internet, right? Well, not this free software. If you get some bootleg software from the internet, people will wrap it viruses in there, right? So you run this program and you have to run an installer that runs an administrator, right? And it's just going to sneak a nice little virus into there that allows them access to your computer at any time, and then they can go on to make money off your computer, right? So it's an interesting model. You just have to worry about what's actually going on with it. So if you bought one from a company and you didn't have to do any of this stuff, you wouldn't have to worry about actually other people breaking into this phone for you, unless you broke into the phone and you knew how everything worked, and then you can trust yourself, right? Hopefully. So we have the stack growth in a computer, right? So each one of these blocks is a stack, and then as every function gets called, right, we added another stack frame, right? Inside these stack frames holds all the variables, like strings that say hello or whatever, right? So if someone types something from the command prompt, or types something in an entry field and presses enter, right? It's going to go into it could go into some piece of memory inside one of these stack frames, right? So the stack will grow, and it grows, it's gigantic, right? Like if I zoomed out of what a stack frame looked like on a computer and had some measurement, right, it would just be like a pencil thin line, right? Less than a pixel on the screen. So it's gigantic. So it keeps growing, and then at this endpoint, there's a buffer at the bottom of that frame, and then at the base of each of these frames, right here, right, for each of these frames, there's an address of where it should go next, right, of what program instruction should be executed next. So if you can fill this buffer too much, it actually overwrites this return address, and then the person who wrote some string, they say like hello, and then hex A12475, right, and it just overwrites the return instruction, and then that thing that they typed in is where your computer actually points to execute code, right? So they're doing this when you break into your devices or anything, right? And then this is what the instructions kind of look like on that level. So you kind of have to mess with this stuff to make that happen. But this is the raw stuff that's executed on the CPU, right? So this is GNU. This is the GNU instruction description. There's like an Intel one too. They do the same thing. But you have move out, call. So after these call functions are every time you build a stack, a new frame on the stack. So very cursory view of buffer overflows. Maybe you can play with them when you get to college. Or I don't know now. Okay, so the next point is internet freedom. Right? So these principles for freedom of software extend a lot into the real world, and when we talk about liberties on certain things. Right? So a big discrepancy with laws today, right, is we have the physical world, right? So if you look at, when the colonists came, they saw this, and there was no California, right? So they were like, we have this is what the world looks like. And what if they just were like, well, the rest of the world looks exactly the same, and it's the same exact thing. So that's wrong. Hopefully you guys see, because unless you haven't, it's not. Yeah. So yeah, I've been to California, but before there, I could have generally thought of this. But that's not the way that it actually looks. So the way these laws are written for like theft and stuff like that, and like digital realm crimes, right? They're thought of with the same terminology that is used in the physical world. So these things are actually different crimes, so should be treated differently. They don't have to be legal, but they shouldn't be. They're not the same, right? So a good example. Yeah. So this is the way it does look. Right? So a good example is the word piracy. So piracy is not a nice word, but it's not theft, right? It's different. It's something. It could still be. If we want to deem it illegal, then it should be illegal, but it should be explicitly written as something else. So this is a handy graphic, right? So this is theft on the left, and then piracy is not theft. It just makes a copy, right? So it's different. Whether it's still illegal, it's pretty much just freedom of information, all right? Like they're just zeros and ones. I could talk. One method of when companies have said no, you can't, send someone information or code or something, they make like haikus that are code, and then they send those to people, and then they're haikus, right? So there's a big thing with like the DVD encoding years ago, and people wanted it, and they said, no, you can't bring this code over here. So they just wrote a haiku that was like 300 pages long, and it was the source code to like a DVD decryption, and then they sent that. The paper copy is in like a mail package, and then they scan it in on the other side and reassembled the program, compiled it, and then they could play DVDs. So there's a weird line between what is freedom of information, what is free speech, right, and what is bits, right? So I think bits are the same as me talking to you, but I don't know. So another piece of internet freedom that we should talk about is the safe harbor principle, right? So this was a recent debate. I don't know if you guys have heard of it. So you've heard of these. So who's heard of SOPA and BIPA? All right. So who called their representative and said, okay, good, awesome. Okay, so this is safe harbor principle, and YouTube and Wikipedia, right? They have to adhere to this, right? They're granted this, right? Because they are a safe harbor. So people make accounts on YouTube and they post content, and then if someone wants to get mad at them for this content, right? They contact the user, right, on this platform like Wikipedia. And they say, oh, on Wikipedia, they would just delete it, right? Because anyone can edit it, right? But on YouTube, you'd contact a user, and you'd say, you need to remove this content. It's infringing on my copyright, right? So YouTube has the safe harbor where they're not in the middle. They're hosting this content, but it's user-submitted content, so it's not them, right? So these bills aim to remove that, right, to the point where YouTube would be liable for hosting this copyrighted content. So in turn, they would say you can't upload anything to YouTube unless someone manually inspects it to say it's not infringing on someone's copyright, because they'd get in a lot of trouble, right? But it was more than that. So there was this section, immunity, taking voluntary action against sites endangering the public health. So that's in a Stop Online Piracy Act. I'll just make that bigger. Okay, that was as big as it gets, right? So that doesn't make any sense. So there's all going on with that. So this blew up, it got a lot bigger. There were a lot of people angry, and I can tell you what happened next, right? So this is not the way stuff looks, right? So we're good for now, right? But I want to emphasize point 3, so I won't read it, but you can look at it, okay? So a recent debate that I wanted to talk about, right, was this question: should publicly funded research be sold by private companies? Right. So who thinks who's yes? All right. Who's no? Okay. So maybe you guys are maybe recalling the recent events on this whole thing. So NSF is a funding agency for doing research. Awesome funding agency, right? They give money to researchers to do research that just makes life better for everyone, right? And also increases, national security. But like they'll be funding stuff that's like solar energy and all this cool stuff that we want in the future, right? And this researcher submits their paper to JSTOR, right? And then JSTOR turns around and charges other researchers for that research, right? And then it doesn't says like you don't have access to this. This person gives up copyright for that content to submit it to some thing that's indexed on JSTOR. So this other researcher is paying JSTOR and the NSF through their tax dollars for the same research, so that they're getting charged more. So like the money kind of circulates, and then it just gets sucked into this thing, right? So that's the overview of the debate, right? So a recent question is whether it should just go over to that person, right? So who knows what this whole debate is about? All right, so God, this guy's name is escaping me. Aaron Schwartz. This is the whole Aaron Schwartz incident. If you haven't heard about that, right? So this was his most recent debate, that he was going to go to jail for like a long time, or longer than it was reasonable for downloading these things. Okay, so the next part of the talk, I want to get into how practical Foss is. So I want to show you. So basically, you have desktop Linux, right? And it's awesome, and works, whatever. It's a desktop computer, right? You have Word, or you have a thing that's like Word, right? A thing that's like Excel, and then you have Google Docs and all these other things. But really what sets it apart, right? Why people use it, is not only for the philosophy, but for the power that they gain when they're using these machines. So if you talk to these people down in the pit, right, that are doing these things, right, you'll see them typing in a shell, right? They don't do that because it's harder, right? They do that because it's easier. So the first thing, right, is You can do more with text-based, right? So everyone's afraid of it. It's like, you can't click, right? But I don't like clicking, right? So I don't have to, right? So have you ever do some long process and then you have to do it 50 times? If you just copy and paste that and then write a script that does it 50 times for you, you've really only done it once. And then maybe a half because you have to you have to copy and paste it. Right? So that's the work is in copying and pasting and not actually doing it 50 times, right? And then you can do it automatically, right? So you can have done something once and you kind of encapsulate what that is in some script. And then someone else can do it, and you don't have to show them how to do it. You can just say, here's a script. You can read it if you want, but just run it, and it'll work. What makes that possible, it looks like the eye from Lord of the Rings, right? But this is the pipe character. It's on top of your end return key, right? It takes in characters and then spits out characters, right? It's used in this bash terminal to move characters around, right? So we're going to go through an example. Let's see it here. So this first example here, we're gonna cat, right? We're gonna type in this command. We're gonna type in this prompt cat, and then we're gonna do an angle pipe, right? To names.txt, right? And then I'm gonna type a bunch of stuff here. Joe, Steve, Veronica, Bob. Joe, Steve, Veronica, Joseph, Bob. And these are gonna be in that file, names.txt. So I just made a text file that easy, right? All right, so we can just cat the file now. If you don't use the pipe character, it just prints out what's in names, right? So we're gonna build on this. One of the principles of this, right, that I'm going to try to show you is that you're supposed to have these core set of utilities, right, and you piece them together to make larger things, right? So what people usually do is, they want to program, right? But you can't just, when people are doing really obscure things on computers, you can't just go download some little utility that has, you browse for a file and you press a button and it works, right? You have to actually prototype these things rapidly, and then so if you get good at this stuff, you can make anything happen in just a matter of minutes, maybe seconds, depends on how good you know these utilities, right? So I'm going to introduce this pipe character here. I'm going to grep, right, which is another command line utility for J, right? And it's going to print out, so we can see the difference here, right? So that's the regular output, and then I'm taking all the characters that were printed there and I'm putting it into this program grep, and it's going to filter for everything with a J. We can filter for everything with a V. We can be more specific and do ver, right? We only get Veronica back. And then we can also do this dash V. So that's an argument that we're going to pass. We're going to say, the V is saying, filter for everything that does not contain a J. And you see that this is the inverse, right? There's no J in any of these words, right? Okay, so that was like a toy example on how to do this stuff. It should introduce the concepts to you. So the next example I'm going to show you is, so you have all these PDFs on the internet, and you want them on your hard drive. All right, so that's something. I like reading PDFs. So, okay. So this thing called archive, right? It provides you open access to research papers. So they're mostly physics. A lot of physicists do this because they want to publish a paper, and in 30 seconds, another person on the other side of the world can read that paper, right? And then it's archived forever, right? And it's a collaboration between a bunch of universities, but Cornell hosts this one. So we can do a search. I'm going to search for algebraic geometry, right? And you just use this URL. So we have we're searching for math.ag, right? On that page that we see here, we have a little PDF link right here, right? You can see that link that's right there. So in the source code, how many people have view sourced on a web page before? Okay, so if you look at that, you're reading the HTML that came back from that server. So we can actually see that that's the same PDF that's written on the other side. And then the link, the href, right, is this /PDF and then some numbers, right? That's what we want. That's the PDF file. That's what we want to download. So if I was to paste that in the URL and do archive.org/PDF1301. whatever, right? I'm going to be able to view the PDF. But I'm lazy, just like everyone else in computer science. So this is a program that's going to download all these for me, right? So I'm going to show you how I built that program, and I think it took me a minute, right? So first, this is going to enumerate all the PDFs on a web page, right? And then it's going to download all those PDFs into a folder. So the first thing I'm going to do is curl. We're going to curl, which is a utility for downloading web pages, from this URL, and here I'm searching astrophysics, right? And I'm going to pipe that into page.txt, right? So page.txt, we can look at it with this program called Emacs, best editor. There are a bunch of editors. Everybody's really opinionated when it comes to this stuff. So there are different utilities that people like to use for different things, right? And everyone has their own flavor for doing this stuff. So I'm going to open up this thing in Emacs, and then I'm going to search for the line that says PDF, right? Just to make sure that that's the file we downloaded, right? And you can see where it says the PDF. So over to the right here, we have PDF. Let me just highlight that, right? So we have this href is there on this file we just downloaded with curl, right? All right, so what we can do now is cat page. So we're going to cat the whole HTML file and then grep it for PDF. So it's going to give us every line that has PDF in it. So you can see these are actually repetitive. These DTs here, that's each line. Right? So they're pretty big lines. Yeah, there's another DT right there. Okay, so this command awk. So we catted the page.txt to grep, right? And we grep for the word PDF. And then we piped it again to another. So you chain these together to do about anything, right? So this program awk, we filtered for double quotes, right? So if you look at this text before, there are a bunch of double quotes all along this thing. And then two double quotes, or there's a double quote on each side of that PDF link you want, right? So I'm going to filter, and it's the 10th set, after the 9th double quote, there is this link that we want. So now I have a list of all the PDF URLs there, but they're just relative, right? They're not a full URL that I can download, right? So I can just append, so I can get a printed version of it, this archive.org URL, right? So now we have these full URLs. If you copy and paste these in a browser, you download them, right? So I'm going to use the angle thing to pipe it into a file called PDFs, right? So now PDFs is full of, it just looks like this, right? So that's pretty crazy. We just parsed a web page, right, and got the actual content that we want out of it, right? So we can loop on the command line. It's something very interesting for Bash, right? So if you want to vary something on each command, I'm gonna do for I in, and then I'm gonna execute a command within a command, right? So I'm gonna execute cat PDFs. So that's gonna give me a huge list of PDFs in this for each loop, right at the top. So for I in this huge list, do echo $i, which is gonna say for each line, echo it, right? All right, so what can we do with that? We can write cowsay. So we can do cowsay this thing, right? And see, it's going to run cowsay for each one of those lines, right? All right. We can also, we can use this command wget to grab a URL, and it's just going to save it onto the computer. So it's wget and then the URL we want to download. So we can run this command for I in cat PDFs, do wget $i, right? So it's going to wget that URL that we're just iterating through. So we had a cowsay it, now we're going to just download it, right? So you run this command, and you have a folder full of PDFs. And there are a bunch in there, right? So you can be as lazy as possible, and this scales, right? So if this was, you might say, oh, it's 10 PDFs, or it's 100 PDFs. I'll just do it all by hand, it's fine, I'll just click a bunch of times, right? But this scales to like millions of PDFs. Every PDF on archive I can download with this method, right? You vary it a little bit so you get all the different fields that they have in there. Okay. So I hope that example showed you. This is how people do this crazy stuff on computers. When they just type away dramatically on a computer, right? They can build stuff that does that really quick. And just kind of hacking pipes together. So they're pipe fitting streams of cars, right? Or characters. All right, so Foss is industrial too, right? So you learn these tools, and you might see some guy in a basement doing these things, but it's not. This is a Mars rover. This is not a real picture because there's no camera stand on Mars. This is a computer one. But this thing runs Linux on it, right? So the engineers who built this thing, who sent something outside of our planet to another planet, and then drove around for 7 years, it's still going, right? That's still running Linux on. So we have a Foss rover, right? That's on the planet, right? And it still works. So this stuff works. All right. So there are no really good pictures of our military. Well, they're cool, but they're all violent. So this military is interesting, but this is a quote from our military. When we rolled into Baghdad, we did it using open source, right? So when the stakes are really high, you can read through every line of code that's in open source, right? You can say there is nothing vulnerable in this code. They hope to say that, right? But they know that there's nothing fishy going on with this code, right? So when they roll a tank in and there's a lot of computers on this stuff, they know that someone can possibly in the field fix anything, right? And they know that there's no back doors or anything that's put in by a vendor or something like that. They know everything that's on all these devices. Right? So when security is a concern and reliability, right? When people rely on this stuff, they need to be able to maintenance system themselves, right? All right, and then Google. So has anyone heard of? There's a company called Google. I don't know if you guys have heard. So they're kind of big. So this is one rack. They're probably the biggest company in the world. I don't know. Or they're the biggest. They have the biggest. They have more computers on the internet than anybody else, right? And this is a row of computers, right? Each one with the wires is another thing. So they run like their own modified version of Linux on all these things to compute all the data that we do every day. So whether that's fishy or not, they're achieving this using free open source software. Granted, it's whenever you like move your mouse in Gmail or read an email, right? So forget what they're actually looking at and processing. And just think they're able to achieve that using this. So internally, for all the stuff that's not the engineers, and they do this for the engineers too, but I think their engineers might not all run this. They probably run more obscure things. They have this thing called Ubuntu. So it's Ubuntu, and then there's Google Ubuntu, right? And then this is the CTO for Google. So he makes all the technology decisions. So you'll be a fool to use anything else but Linux. So especially for them. So I guess there was another quote. Their security team was having a hard time with Windows, so they use this because it allows them more security. Right? So I mean, they're a target of a lot of attacks. Right? So they also use Puppet to manage all these machines. Right? So you have machines rogue in like every country probably, right? And they're managing all these things centrally through the system called Puppet. So they're quoted being used to manage all recent Mac OS X and Linux, desktop Linux servers, right? So everything they do is managed by this piece of free and open source software. All right? And it scales because Google has a lot of computers. Right? Then if you look at Facebook and Twitter, right, these are internet companies. They're pretty big. They use OAuth is one of the authentication mechanisms that they use. It's an open method. Right? They're also they make heavy use of Linux, and the variants that they use are CentOS, Debian, and BSD. Right? They want people with experience in all those. So they're sitting on top of this infrastructure, the same thing as Google. And they also use Puppet. Hadoop, which is like Google's MapReduce, that's how they compute all your data, because these companies make a living off data, right? And they also use MySQL and PHP. So PHP, has anyone ever done any PHP programming? It's really like the kitchen sink of web development, right? You can just write some code and does stuff. All right, so down in the blue wing, right, there are a bunch of events going on, right? So first thing is, so you can turn your phones back on, right, once we're done, or now. You can connect to this access point called Foss Hacking and Innovation, right? And it's no matter what site you go to, it's going to redirect you to this game, right? Then you can play this game, and if you get to the end, there are like 11 levels of questions, and you can get hints by talking to these guys down at the tables, right? They won't tell you the answers directly, hopefully not, but they'll give you hints on how to solve these. If you check the wrong answer, you're going to be banned for 10 minutes, so make sure you don't just try to guess. So if you get through, you'll be entered in a raffle to win a Raspberry Pi or one of the 4 desktop machines that are on the build your own PC thing. And they'll make sure it's working before you take it, right? So you're not going to get a machine that doesn't work, because they're ripping it apart down there. All right, so there's that, and then take a look at the other events that are on these tables. So we have build your own PC. You can look at Arduinos, look at the cool projects that are working on that are being shown down there. A Raspberry Pi controlled with Bluetooth, so you're actually streaming audio and video over Bluetooth using the same program that I scanned the room with, right? To this Raspberry Pi, and then it's going to show the video or play the music through a speaker, right? And then Python playing Super Mario, squishy circuits, right? So it's like Play-Doh and it connects stuff. Makey, so it's like touch connectivity. And then the SPAN, ad hoc Android network. So if you're in the middle of nowhere, you don't even need to set up a cell phone base station, right? Which we could do. The phones will talk to each other. So it's some pretty rogue communication, right? So they're actively showcasing it, so you can see them talking without any infrastructure. It's just phone to phone. So it's like the next generation of the walkie-talkie, right? And that's it. So I hope you guys enjoyed the stuff.
Thank you all for coming. thing. If I could just meet up with the chaperones and the teachers at some point, I'll be down in the well. If you could just stop by and talk to me for a second, I would love to catch up.